We are still on a chapter of matrix algebra, and we are introducing the concept of matrix multiplication. So in the previous video we introduced the idea of matrix multiplication. At the end of the day, this is nothing else but the inner product between a row matrix and a column matrix, okay, defined this way, right? So a1 times b1, a2 times b2, okay, you add them all, so that's the sum from k1 to n of ak times bk. Here we took an example, a particular case, a product of two matrices, and we checked that if we have a matrix a dimension m times p and another matrix of dimension q times n, p and q, they have to be the same. So we saw that A will be the matrix AIK, B will be the matrix BKJ, and A times B is defined as a matrix CIJ, where the entries CIJ is AI1, B1J, AI2, B2J, till AIP, BPJ, defined as the sum from I, AQ, BKJ. Okay, check that the right number and the left number here, they are the same. Okay, so we took another particular example. We took the matrix A and the matrix B. This matrix is a 2 by 2 and this matrix is a 2 by 3. And in the previous video we multiplied them. We did this A times B, right? So we had A 2 times 2, dimension 2 times 2, and dimension 2 times 3. Okay, and since this number is the same, we got a 2 times 3, right? A 2 times 3 matrix. Now I would like to call your attention for the fact that you can do A times B, but you cannot do B times A. So you see you're doing A times B here, but you cannot do B times A because this is a 2 times 3 dimension matrix and this is a 2 times 2. So this number is not the same. Okay? So if you are a beginner, this is your first non-commutative ring. Okay? The matrices, the ring of matrices is a non-commutative ring. So A times B is possible, and not only A times B can be different from B times A because the ring is not commutative. Not only that, but A times B is possible and B times A is not possible due to the difference of dimensions. Okay, now let us suppose that we have three matrices A, B and C in the same ring, of course, same dimension, and a K, a scalar. So matrix multiplication is associative. So A times B times C, if you first multiply A times B and then you multiply C, is the same as A times B times C. And matrix multiplication is also left distributive. So A times B plus C is the same as A times B plus A times C, and is also right distributive. So B plus C times A is the same as B times A plus C times A. And the same is valid for the scalar product. K times A B is the same as K times A B and is the same as A times K B. Okay, I should provide some proofs for some of this. Let me see. Okay, let us prove the first one. So A will be matrix AIJ, B will be matrix BJK, and C will be matrix CKL. So A times B will be matrix S, and that will be SIQ, right? This high here and this Q here, because it's the product of AB. And BC will be matrix T, big T, and that will be small t. So BC, it will be J, this one, right, times L, this one here, TJL. So SIQ, this one, will be the sum from J1 to M of AIJ, this one, times BJK, right, times that one. And TJL, this one, will be the sum from 1 to N. I'm going to, this one, M for monkey, and this N for nun, okay, because they don't have to be the same. TJL will be the sum from K1 to N of BJK, right, BJK here, times CKL, okay. So we have to multiply S, this one, by C, by this one, right, where S is AB. Okay, so we are going to have AB times C, right? So that will be A times B times C will be the sum of SIQ CQL. We saw that, so this is S, right? This one is S, SIQ, and C is QL, so that it's this one, okay? A times B times C is this. At the end of the day, this is nothing else because SIQ is A times B, right? And since it is A times B, it is A times B, so it will be the sum, the double sum of AIJ BJK times CQL. So I already have ABC. What do I need now? I have AB times C, it is this. So now I need ABC, right? A times BC. I'm proving that those two are equal. Okay. So I'm going to keep writing on red now. So A times BC, it will be A, that's the A from here, right? So the sum of AIJ, and BC is this one, BC, so that's TJL, but T is BC, so that's the double sum of AIJ, times, so TJL is BC, okay, so BC is BJK CKL, BJK CKL. Okay, so as you can see, this one, double sum of AIJ BJK times CKL is equal to AIJ BJK CKL, because the product here, this is a product inside the sums, okay, this is totally associative. So A times B times C is equal to A times BC, and the first law is the associative law is proved. So we just proved the law, the associative law. A times B times C is the same as A times BC.